For this video, we are going to learn how to use matrix analysis to find solutions for the systems of linear equations. Now, a question comes to our mind. How are we going to transform a worded problem into its corresponding system of linear equations? And for that, we need to consider the two types of data. The first one is numerical data, which uses real numbers to measure a parameter with any desired precision. This is also called quantitative data. Examples would be height, weight, and age. If a parameter cannot be expressed in terms of numbers, then it falls under categorical data. It tells us information whether an individual belongs or does not belong to a certain category. This is also called qualitative data. Examples would be hair color and age groups. Now let's focus on categorical data, because categorical data is what we are going to use in solving systems of linear equations by using matrix analysis. Tabulate the categorical data in a matrix. We have a group of students who were surveyed about their eye color and skin tone. The results are as follows. So this kind of survey is an example of two-variable data because we are curious about their eye color and their skin tone. So the result is as follows. 10 have fair skin tone, 11 have medium tan skin tone, 10 have deep tan skin tone, 4 have green eyes, 14 have blue eyes, and 13 have brown eyes. So each of the students have a combination of a skin tone and an eye color. And it is expressed using the matrix A shown below. So we have here matrix A from our example. Take note that the columns represent the eye colors of the students that we surveyed. And each of the rows represents the skin tones. So each of the student will only have only one eye color and only one skin tone. So for the first column, these are the students which has green eyes. The second column, the students with blue eyes. And the third column represents the students which has brown eyes. For the first row, these are the students which has a fair skin tone. The second row represents students with medium tan. And the third row represents students with the deep tan skin tone. So, if we are asked how many students have medium tan skin and blue eyes, so those students which has medium tan skin tone and blue eyes, that would be number 7. There are 7 students with blue eyes and medium tan skin tone. And if you are asked how many students have green eyes, so for the students with green eyes, that is just the summation of these 3 values. 3 plus 1 plus 0. 3 students with green eyes that has fair skin tone, 1 student that has green eyes and medium tan skin tone, and 0 students which has green eyes and deep tan skin tone. So, those with green eyes are a total of 4 students. If you are asked how many students have deep tan skin, so those are represented by this row. So there are 0 plus 2 plus 8 is equal to 10 students which has deep tan skin tone. And if you are asked how many students have been surveyed, for that is just the total of each of these entries. That would be 3 plus 5 plus 2 plus 1 plus 7 plus 3 plus 0 plus 2 plus 8. So there are a total of 31 students that have been surveyed. So that is how you use matrix to transform a categorical data to utilize them in solving systems of linear equations. So let's have this example. A farmer sells his produce in the market during weekends. He sells kiwis and apples. On a certain week, he sold 10 kilograms of kiwi and 20 kilograms of apple. That is on a Saturday. The next day, he was able to sell 20 kilograms of kiwi and 15 kilograms of apple. The price for the apples is 100 pesos per kilo and 200 pesos per kilo for kiwi. Calculate the total revenue for that week. So now let us transform the worded problem into its corresponding matrix for us to solve the total revenue for that certain week. So this is for the kiwi and for the apple. For the first day of that week, that is a Saturday, the farmer was able to sell 10 kilograms of kiwi, and he was also able to sell 20 kilograms of apples. The following day, that is a Sunday, the farmer was able to sell 20 kilograms of kiwi and 15 kilograms of apple. And the prices for the kiwi, this is the price, is 200 per kilo. And for the apple, he's selling it for 100 pesos per kilogram. So let's construct a matrix A. This would be kilograms of kiwi and 20 kilograms of the apple. So let's make this row the number of fruits that he was able to sell on the Saturday. For the Sunday, the following day, he was able to sell 20 kilograms of kiwi and 15 kilograms of apples. Take note that we are being consistent with where we are placing our values. So this is for the kiwis and this is for the apples. The column represents the days or the column represents the fruits, the type of fruit, and the rows represents the day on which the farmer was able to sell those fruits. So since we are curious about the revenue, and revenue is equal to the number of kilograms of a fruit multiplied by the price. So that is how you compute your revenue. Let's try to create another matrix for us to compute the revenue of the farmer. So, since in matrix multiplication, we are using the process of row by column multiplication, this row will be multiplied by whatever is in this column matrix. So, the 10 kilogram of kiwis should be multiplied by the price of the kiwi. That would be 200 pesos. And the apples, that is 20, will be multiplied by the price of the apple. That is 100. So that if we multiply this row by this column, we are going to obtain the total revenue in the Saturday. And if you multiply this row by this column, you are going to obtain the total revenue on the Sunday. So let's try to multiply these two matrices. We have here AC is equal to 10, 20, 20, 15. And C is the price. This is 200 and this is 100. So if you are going to multiply these two matrices, let us check their sizes if it is compatible. So this is a 2 by 2 matrix. Matrix C is a 2 by 1 matrix. So since these two numbers are equal, the product is defined. And the size of the product of AC is a 2 by 1 matrix. So let's do matrix multiplication for this. This would be 10 times 200 plus 20 times 100 and 20 times 200 plus 15 times 100. So the total revenue AC this would be 10 times 200 plus 20 times 100. This would be equal to 4,000. And 20 times 200 plus 15 times 100 or 1,500 is equal to 5,500. Now, the shape of the product is a 2 by 1 matrix. Now, what does these two values mean? 4,000 is the total, this should be L, revenue for the Saturday sales. And 5,500 is the total revenue for the Sunday sales. But we are asked the total revenue for that certain week. So to find that, we are just going to add these two values. 4,000 total revenue. This is 4,000 for Saturday plus 5,500 for the total revenue on Sunday. So that would be a total of 9,500. That is how we transform a worded problem into matrices so that you are going to solve for what is unknown in the problem or what is required in the problem.